Surfing is much more complex than it appears. There are so many varieties and types of boards that choosing the wrong board on a specific wave would be similar to using a saw to hammer nails. Using calculus, specifically finding the area between two curves, relates heavily to surfboard shaping and design, specifically the cross-sectional area and the surface area of the board's bottom plane. These measurements play a huge role in what type of waves can be ridden on a certain board, whether or not the board can catch a specific wave, and how the board performs in the water.
So here we have the graph of a gun type surfboard. It's not a gun, it's just a gun surfboard used for big wave surfing, like you saw in the intro. Here's the top equation that we have labeled as f of x, which is this top line from here to here. And the bottom is also a piecewise function from here labeled as g of x, and there's two x-intercepts, x at equals 0 and x at equals 108, and it splits, the piecewise function splits for each equation at x equals 54. So the equation of an area, the area equation between two curves is the integral of b to a of top minus bottom in relation to x, and that gives you the area. So here we have the same thing, but since it's a piecewise function, we have to split it up into two separate equations. So two separate integrals, not equations. So this one right here is this first half of the gun surfboard, and this right here is the second half of the gun surfboard. That's the first half. And we simplified it out, and right here we'll plugged it in. And then we took the integral, and that gave us this. But since it's symmetrical, I couldn't draw it symmetrical, so a little note, blah blah blah. But it's symmetrical on all four quadrants, if you will. The first two, right here, are equal, so we took the integral of 1, then multiplied it by 2, and that gave us an answer of 684. And then we took the second half of the piece of the second integral of the second half of the surfboard, and that gave us this equation right here. And in the first part, if you're wondering why we didn't have this first section, is because b equaled 0, so it took that whole part out, so we just left it out right there. But multiplying that out, plug and chug, we get 108 equals 0, 54 equals 684, but since it's b minus a, we get 0 minus 684, which equals positive 684. So when you add 684 together twice, we get 1,368 inches cubed for our total area of a gun surfboard.
Due to the small surface area on the bottom of the board, drag is minimized, allowing for the board to travel faster through the water. This is important in big wave surfing because of the nature of the waves being ridden. It often becomes a race to outrun the crashing lip of the wave and to avoid serious injury. The smaller the surface area, the faster the board can go.
So here we have the cross-section of a gun surfboard. The graph's a little bit better this time. This reads 0.25 inches, that reads 2.5 inches because it's 2.5 high, that's 2.25 inches. It's 19 inches across, so from here to here is 9.5, from here to here is 9.5, but since this is the y-axis, this is negative 9.5. So again, we do the area between two curves, use an integral, so from b to a, top minus bottom in relation to x. The top equation is this, I cannot read upside down, and bottom equation is this, and that comes out to be exactly the correct dimensions for the surfboard. And same with the ones in the first one, is exactly the dimensions. And this one was a little bit easier to do. We learned this in class, or the equation to figure out the integral, because last one I had to research a bit to find that, and that took a while and it was very annoying. But I got it right, so I'm good. So I take the equation, plug in the x, do all the math. This is top, this is bottom, relation to x. Plug it in, you get 14.2497 for 9.5, because it goes, that would be this part. And then you plug in negative 9.5, and again you get you get negative 14.2497, but since it's b minus a, you get 14.2497 minus 14.2497, which yields you 2.84994 inches squared for the total cross-sectional area of a gun surfboard.
A small cross-sectional area in surfboard design is useful in creating boards that maneuver with greater capabilities. The trade-off is that these boards have less internal foam than others. This limits them to only catching medium-sized waves. However, with the assistance of PWC towing, surfers can get these small, agile boards onto the massive, fast-moving waves of deep water breaks, spots that otherwise would require a big, clunky board with a thick cross-section to accommodate the extra, more buoyant foam.